Justice and Mercy Energy Services presents a brief overview of microgrid architecture types. Well, before we get into the actual architecture, we need to talk about some symbols that we're going to use to describe that architecture. This is a symbol I'm going to use for a source. It's a source of AC output power. The sine wave in the middle of the circle is supposed to be representative of sine wave. We're going to do one-line drawings here instead of two-line drawings. There's two different kinds of, we could draw schematics in either way, but we're going to go with the one line for simplicity today. Now, this could be a utility, or it could be a distributed generator. So we're going to use DG for a distributed generator, and a distributed generator could have an AC output or a DC output, depending on what type it is. For example, some of the AC output types would be a diesel generator. DG also stands for diesel generator. The larger hydropower and the larger wind power turbines also have AC outputs, but DC outputs are well, solar panels are all DC output, and also small hydropower and small wind power often convert to DC first. Another thing we're going to show here, this is a symbol for a switch. I've shown it in an open way where the connection is up. We could also close it and show that we have a connection, but we don't typically show them closed in drawings. We typically draw a little arrow showing that the arrow shows that it can either be open or closed, because sometimes if you close it, it just looks like a line and you can't tell what it is. Okay, so with those symbols, we have one more that's important, and that's the inverter symbol. The inverter is a device that converts DC to AC. So I've drawn a little box with a diagonal in the middle, and what we get is DC comes into it and AC comes out of it. So we have a little symbol for DC is the solid line with a dashed line above it, and a little sinusoidal wave, the little squiggle, is a symbol for AC. So some inverters can be run in reverse. Essentially, they can take a sine wave as an input and make a DC voltage. These are called inverter chargers usually, because the idea it's also something that can charge a battery bank. So here I've got a DG that's an AC output on the left. It goes through an inverter where it gets converted to DC storage in presumably something like batteries. Not all storage has to be in batteries or in DC, but all battery storage has to be DC, but there's other types of storage too. Okay, so the simplest type of connection would be just to have a utility connection to your load that is switchable. And basically, any house in the United States has a master breaker that follows this. I could just disconnect that master breaker. And so if you wanted to think about it that way, your house is a type of microgrid. Okay, but more realistically, we can have a distributed generator with AC output that provides that load, and there is no utility connection, no grid connection. So essentially, like a generator out there powered, if maybe you go on a camping trip or something, if we could have AC or DC types. Now, the second one I've shown, well, excuse me, this one has storage. So if I'm going to have the ability to store it, I need to store it in DC form. So the AC power can go straight to the load, or some of it can go through an inverter charger that goes into storage and then comes back out to the load as necessary. I could also have a distributed generator whose output is DC, such as solar panels. Okay, those could be connected to storage on the DC side of the inverter, and then the load, being AC, is on the AC side of the inverter. So here, the energy can go in and out of storage and eventually to the load. So Justice and Mercy Energy Services designs, installs, and maintains solar energy systems in Haiti to combat energy poverty and create jobs. So please consider making a donation at our website. Thank you.